This is Angles and Their Measure, page 2 of the packet, Unit 7. That first page is Practice Simplifying Radicals. So I'm going to go ahead to page 2 in the packet. Trigonometry, we've said, is where geometry and algebra come together. So we need to go over a little bit of vocabulary. When I have a circle that is sitting on an XY coordinate plane, I'm getting ready to start talking about the unit circle, which is a special circle that sits on the XY coordinate plane. And so in preparation for that, let's remember angles and how to find them and their measures around a circle. So you can see the X and Y axis here on our diagram. The circle is sitting in the center. The center of the circle is at the origin. 0, 0 would be the coordinate there. And there's also a right triangle that's formed inside of the circle. The first thing I want to do is go around the circle and mark each angle measure where the circle meets the X and Y axis. So I'm looking at this right here. We start at 0 degrees, and this spot here is going to be our start and our finish. So we start at 0 degrees. A full circle is a total of 360 degrees. So both of those land here at this particular spot. Up at the top of my circle here where it meets the y-axis, this is at 90 degrees. This point over here, a total of 180 degrees from start to this spot, and that is half of our circle. We've made it halfway around. Each quadrant is divided up into 90-degree sections. So from 180 degrees, I'm going to add another 90 degrees to that, and that puts me down here at the bottom at 270 degrees. And then when I add 90 degrees to that, I land here at 360 degrees. So 360 divided by 4 makes up the 4 quadrants here. Start at 0, 90, 180, 270, all the way to 360 degrees total. The way that we name each of the quadrants is using Roman numerals and in a counterclockwise direction. This here is quadrant 1. And then to the left, going counterclockwise, this is quadrant 2, quadrant 3, and quadrant 4. Okay, no matter what, these are the names of the quadrants, and regardless of how we are forming angles around the circle, the quadrants' names are going to remain the same no matter what. And we use Roman numerals to indicate the quadrants. Okay, when I'm drawing an angle, and you see that we've got theta there in the center, we've talked about theta in the past. I'm going to start at what's called the initial side. So the initial side is where I begin. So beginning at 0, the initial side is here on the x-axis, initial side. This is always where I'm going to start in order to draw an angle. Depending on however many degrees I'm given, I'm going to need to draw an angle. And so I'm going to start here at 0 degrees on the x-axis. And it's called the initial side. Initial meaning where you begin. The terminal side is where the angle ends. So terminal side is the side of the angle that marks the ending. Okay, and so that name terminal side is important for us to recall because I'm going to need it. Remember what the terminal side is. The terminal side is this side here. It's the side of the angle where the angle ends. However many degrees I've been told to draw. Once I find that many degrees and I draw the angle there, the terminal side is where that angle lands. So the angle that we're talking about now is called theta. Remember, theta can be moved around. It can be in different places. And in particular, our theta is always used to mark our reference angle. So the reference angle is the angle that we're going to use in order to do any of our trig operations that we learned in our last unit. So we call the reference angle theta. We call the reference angle theta, and it's the angle that we use to form our right triangle in order to be able to use our trig functions. The reference angle is always positive, and it's always adjacent to the x-axis. It's always on the x-axis. Okay, so drawing an angle in standard position, that's what we call it when we start at 0 and draw around the circle in a counterclockwise direction. Angles can be positive or negative. You can have a positive angle measure and you can also have a negative angle measure. A negative angle measure just means that you start at the same place but go in the opposite direction. Positive angles always rotate in a counterclockwise direction. Counterclockwise means from your starting point, you're going this direction. And then if it's a negative angle, it's going to rotate in a clockwise direction. So a negative angle measure starts at the same place. It starts on the x-axis at the initial side, but you go down first. You go down first in a clockwise direction. Okay? The reference angle is the angle that we use to form a right triangle with the x-axis. Always with the x-axis. Reference angles are always less than 90 degrees. Okay, reference angles are always 90 degrees. Excuse me, always less than 90 degrees. So that would mean they're always acute. They're always acute angles. They always touch the x-axis. They're always a positive degree measure. And these are the angles that we use to do our trig functions with. Lots of things to remember about the reference angle. So when I mark the rotation, it's called marking the rotation, I'm going to move around the circle in whatever direction I'm given. Positive would be counterclockwise, negative would be clockwise. So let's take a look at how we draw an angle. If I'm given this example here, 120 degrees, I want to draw an angle that measures 120 degrees. So I don't mean go grab a protractor and try to measure it out. We're using our XY coordinate grid. We know we start here at 0. One trip all the way around would be a total of 360 degrees. So here's 90, here's 180, Here's 270. So 120 degrees is somewhere in between 90 and 180, right? Somewhere in between there. Where you land doesn't really matter a lot as long as it's in the correct quadrant. So what I'm going to do here is draw my terminal side. So 120, I'm going to estimate that to be about here-ish. So I'm going to draw this angle with arrows. I write 120 degrees right here next to the arrow. That indicates the measure of that angle because that's what I've decided. I mark the rotation by starting at the initial side and drawing an arrow to the terminal side. So this is what we call marking the rotation or showing the rotation. I show where I started, I show where I end, and I show it's in a positive direction. From there, we have to label and find the measure of the reference angle. So the way we do that is by forming a right triangle from the terminal side. So right here where it defines our reference angle, the angle that we use to form the right triangle. It comes from the terminal side of the angle. So from here, I do what's called dropping a perpendicular. I always go to the x-axis and draw a right triangle. So here's the right triangle I'm going to use. Theta is my reference angle, and it is this angle inside here. So the 120 degree angle that I drew is from here to here. This is measuring 120 degrees. However, my theta has to be touching the x-axis. My reference angle has to touch the x-axis always. So the reference angle is going to be this one here. The reference angle also has to be inside of a right triangle. So that's what I did here. I formed a right triangle. I'm labeling that theta. Now I have to figure out how many degrees is my reference angle. My reference angle is called theta, and I need to know how many degrees it is. I know from here to here, it's 120. And I know that 180 is here. So it's between 120 to 180 that gives me the measure of the rest of that rotation. So I would take 180 and subtract 120 from it in order to come up with 60 degrees. So my reference angle is 60 degrees. Okay, so now let's take a look at a negative angle and how we draw it and what it looks like. Over here, I've got negative 165 degrees. I need to draw that angle. So if I'm moving in a negative direction, I always start at the same place. This is my initial side where I start. But if it's negative, I'm going to start here and go down first. I'm going to rotate in this direction. I'm going to rotate clockwise. So I need to find negative 165. It's not as complicated as you might think. Since I already know where the x and y axes are, and I know that, for instance, this is 0, up here at the top is 90. When I lay flat, it's 180. Do the same thing, but just go in the opposite direction. From 0, now go down. This would be negative 90 degrees. This would be negative 180. And up here, negative 270 degrees. All the way around negative 360 degrees. So moving in the negative direction, those are my negative angle measures that I know of. If I need negative 165 degrees, I'm going to start at my initial side. I'm going to travel in a negative direction this way, and somewhere in here is negative 165. So let's draw that terminal side. There we go. Label it. This is negative 165 degrees. I've shown my rotation. I've moved in a negative direction to get to this angle. It's negative 165 degrees. Now I need to find theta. So remember what we know about theta. Theta is always touching the x-axis. It is always at the origin. It's always going to be positive, and it's always going to be inside of a right triangle. So all of those things point me to that spot right there. Now from there, what I do is I drop a perpendicular line from the terminal side to the x-axis. There, I've now formed my right triangle. My theta is inside there at the origin, so I need to figure out how many degrees that reference angle is. So I need to figure out how many degrees are in here. From negative 165 to negative 180, I need to know how many degrees are in there. So from 165 to 180 would be 15 degrees. If you wanted to go to your calculator and subtract 165 from 180, you would find that your result is 15 degrees. So the reference angles always have to be positive. So the negative only indicates that you're going in a negative direction. The measurement itself is actually a positive, but you've moved in a negative direction. So here my theta is 15 degrees. Okay, let's look at a couple more examples. If you want to pause and give it a try yourself, that would be a great idea. I would like for you to go ahead and change this one. Instead of doing 160 degrees, let's change this to be 280 degrees. That way it'll give us a chance to land in a different quadrant. So change this to 280 and pause and see if you can draw the angle that's 280 degrees and then fill in this information. So this lands in quadrant 4. The terminal side of this angle is in quadrant 4, and it wants to know what is theta. Theta is going to be from 280 to 360 degrees. So I can go to the calculator if I want and subtract 360 minus 280, or however you come up with that the easiest. But from 280 degrees to a complete rotation of the circle, this measurement here has to be 80 degrees. So 80 degrees is the measurement of theta. Theta is my reference angle. Okay. Let's do a negative angle. So underneath here, a negative angle. Start at 0. This is negative 90 now. I need to go negative 60 degrees. Negative 60 degrees lands me in quadrant 4. The terminal side of negative 60 degrees lands in quadrant 4. Drop your perpendicular line from the terminal side to the x-axis, and then your theta is always at the origin and always touching the x-axis. So theta is going to be this angle measure here, and it's actually going to be exactly 60 degrees. It's always positive. The reference angle always has to be positive, and it's exactly 60 degrees from the x-axis to the terminal side of that angle. Okay, over here, 405. So this angle is more than one whole rotation. So 0, 90, 180, 270, 360. So one rotation around a circle is 360 degrees. This one goes even further. It actually goes another 45 degrees, right, to get up to 405. So once I've determined 360 plus 45 is going to give me a total of 405 degrees. Now watch how I mark the rotation on this one. Uh-oh, you know what? I haven't done that. I didn't do that for my last example. Sorry about that. I need to draw the rotation. So for example 3, start at your initial side and draw your rotation. We had to go down in order to get to negative 60 degrees. For a positive angle, I go up first. So I start here. I go all the way around. So here's my rotation showing 360 degrees. And then I have to keep going a little bit more in order to get up to 405. So a little curly Q sort of thing in there showing the rotation. Now do the same things we've done for the others. Drop a perpendicular line from the terminal side to x-axis. Make your right triangle. Mark your reference angle. The reference angle is always touching the x-axis, touching the origin. And in this case, it's a 45-degree reference angle. And we have landed in quadrant 1. And then really quick, I'll show you this one. When it lands in the first quadrant, sometimes it's a little awkward because the reference angle is the same number as the actual angle measure itself. So here's my rotation. This is 45 degrees. Draw my right triangle. Theta has to touch the x-axis. And so my reference angle theta is 45 degrees. In this case, it's the same number as the angle measure that I drew. Okay, now let's talk about coterminal angles. Coterminal angles are angles that have the same initial and terminal sides. There's infinitely many angles like this. So the first example shows an angle of 60 degrees. So if I'm drawing my rotation, I'm starting here and going here, and I've measured 360 degrees. Now I can go around the circle as many times as I want to. So if I continue to go all the way around and land here, then I'm landing at the same spot. It says the same terminal side. So my terminal side is here, and I landed here, but in order to get there, I went all the way around the circle one whole time. So when you go all the way around the circle, another rotation, you're adding a whole 360 degrees in order to get to that spot. So I'm going to take the 60 degrees I started with and add a whole circle to it. And I come up with this angle measure, which is considered coterminal. Now, another way I can get an angle that measures at that same terminal side would be to go in a negative direction. So let's say this time I start at my initial side and I want to get to that terminal side, and I'm going to get to it by going in the negative direction. Instead of going in the positive direction, I'm going to go to the negative direction. So what I've done there is I've basically subtracted part of that circle from it. So I take my original angle measure, I subtract the 360 degrees, and I get an angle that measures negative 320. So this has a lot of properties that can be helpful and that we can see important stuff later on down the line. But for now, the basics are, we don't need to make it overly complicated. The basics are, you're going to take the angle measure that they give you and you're going to add 360 degrees to it in order to get one coterminal angle. And then you're going to take that angle measure they gave you and you're going to subtract 360 from it. In order to get two coterminal angles. So these two angles that I have just found down here, these two angles are coterminal angles. So looking at this next example, I've got negative 135 degrees, negative 135. So I would start here and go in the negative direction to get to negative 135. Then I could add another whole rotation, add a whole circle to it, and get another angle that lands at that same side. So I would do negative 135 plus 360. And also I could then get to that same terminal side by starting at my initial side and going the other direction, going in the positive direction there, basically. So negative 135 minus 360, and I get negative 495. So really what you need to know in order to find coterminal angles is you take the angle that they give you and you're going to add 360 and then you're going to subtract 360 and you're going to tell me those two angle measures are coterminal angles. These two that I just found are coterminal with negative 135. Coterminal meaning they land at the same ending side. All right.